Okay, so I'm gonna first just start off by filling these cups with our cabbage solution. It's probably good. It's a pretty good purple color. Okay, so we got all of our cups filled. Next, I'm gonna be adding a half a cup of water into each cup. Get me to hold the cup. Yeah. That's probably good. Oh, I think we diluted it too much. That's okay. Yeah. Sorry. Yeah, okay. So we got it diluted. Now we'll add each one of our chemicals into the cup. So today we have lemon juice, which is really acidic. We have baking soda. We have ginger ale for our soda and then just vinegar. So first, we'll start off with some lemon juice. So we'll do it in this cup. Ooh. Next, I'll do ginger ale. Should I pour more or leave it? That's good. Okay. Then we'll do our baking soda in the third cup. Ooh, okay. Next, I will do our vinegar. That's a cool color. Good. Yeah. Okay. And then this is just gonna be like our water cup. Yep. So this is all of the colors that we got. These are the back two cups. You can kind of see that it's blue. This one's more of a neon pink, which is pretty neat. And then you can see the other two. Okay, let's see. So we have this one that is neutral. So in the second part of the directions, it says to add something more acidic. So we don't have fruit juice, so we're just gonna add some lemon juice to it. Which comes out a pinkish color, essentially. Okay, and then, so we do have one that is pretty acidic. So it says it wants us to add as a base, which is baking soda. So this one looks like it's probably the most acidic, so we'll add some base. Oh. Whoa. And then we have to stir all of them, right? Yeah. Okay, so we'll just go ahead and stir all of our solutions. See if we get any significant color change. So this one did turn blue. So it says it's like a detergent. So it has like a blue-green color to it, which is pretty cool. And this one is just like a light blue. Cool. And then, okay, so now we're on part 2. Okay, so we're gonna set 2 cups up. And I'm gonna put our cabbage pH indicator in there. And then it says in each one of those cups to add a cup of water. So we'll go ahead and add some water. So a little bit more than last time, for sure. You know, whole cup it says. And then, yeah, so it's hard to tell, but it is like a really light purple, like it says in the directions. So I'm gonna go ahead and blow bubbles. And I'll be the timer. And she'll be the timer, so tell me when to go. All right, go. I'm making a big mess. It's okay. So as Haley's doing this, she's breathing out carbon dioxide into the water. So after about a minute or two of her doing this, we're gonna compare the color between these two cups and see, well, is there color difference? So originally, like we said, they're both like a light purple. And as she's doing this, I can already see somewhat of a color change, which is actually super cool. What carbon dioxide can do.
Takes the breath out of you. Okay, so definitely a color change.
So I'm gonna put this white napkin up so you can kind of see the difference.
It's hard, but it's definitely like a light pink, and then this one is like a purple. Oh yeah, you can see, yeah.
Yeah.
So there's definitely a color change with those, blowing those bubbles. I feel like if we blew it for a little longer, it would definitely turn more pink. So you can tell that that carbon dioxide definitely does something to that.
Yep, makes a difference.
Okay.
Alrighty, so then we're gonna answer some questions here.
The last two questions in the video. So, do you want me to go first for mine?
Yep.
So number one, it says describe ocean acidification or something like that. So I basically said it's the process when like the carbon dioxide gets absorbed by all of the seawater, and then when that happens, the pH in the seawater is reduced, and essentially that's not very good.
Yeah, there's definitely negative effects on the ocean, especially for wildlife that rely on calcium carbonate for their shells. It makes it a lot harder for those shells to form, or their skeletons. So I definitely think it is a concern, and we should be more aware of the carbon dioxide in the ocean water. And the second question is, are all acids and bases equal pH strength? And we said no. Some of them can be more stronger, and some can be more weak, or some can be more acidic and some can be more alkaline. So no, I don't think that it's equal.
And as part of that question is, should we be concerned, right, about that?
Yeah, and possible consequences.
And so I'm just going to add on to what she said, because she basically hit it, and I'm going to add on that, I guess we should be concerned, because it's like basically harming the oceans, which is not very good, and it can have the potential to like alter the biodiversity that goes on, fishing that goes on, and essentially all the food webs, because we know we get a lot of food from the ocean, and if that's harmed, that's not good.
Yeah, I definitely think that if we don't make a change, we're gonna see negative consequences. So
I agree.
Yep.